Hello class, in this video we'll talk about how to name ionic substances. Now of course ionic substances are made of ions, again remember, cations which are positively charged and anions which are negatively charged, and the combination of those ions make ionic substances, and we need to learn how to name ionic substances. Now there are several ions, there are many ions. We will be required to learn a few of them, the most common ones, and they are represented in this table. Actually, there are some that I would like you to know that are represented in this table, but this table represents the majority of the ones that you should know. Okay? Now, of course, you could just look at this table and try to learn it, but that would be tedious and boring. I already made a PowerPoint for you that I believe that I already emailed you, and it is posted on Al-Khazna. So you can use that to learn this. But let me also say that the naming of most of the ions that are shown here is pretty logical, and we will see that in the next few slides. Now here is an overview. I mean, this slide is going to be an overview of how we name ions. So first of all, ions are made of two categories, or of two kinds. Ions are of two kinds, or they come into two categories: cations, which are positive, and anions, which are negative. Now, both cations and anions can be either monatomic, which means they are made of one atom, or polyatomic. So monatomic, one atom; polyatomic, more than one atom. Okay? Now for cations, that's where it stops. We will learn about how to name monatomic cations, and we'll learn how to name polyatomic cations. Now for anions, it's a lot more fun. So we learn how to name monatomic anions. Now the polyatomic cations are, again, as I said, plenty of fun. So we'll spend a lot more time on that. Now polyatomic cations come in two flavors, or we categorize them into two groups. Well, the ones that have oxygen, so those are oxygenated polyatomic anions, or they are also called polyoxyanions. And the ones that do not have any oxygen in them, so they are just non-oxygenated polyatomic anions. Now, the oxygenated polyatomic anions also come in two groups. The ones that have halogens in them, we call them halogenated polyoxyanions, and the ones that do not have any halogens in them, and those we call them the non-halogenated polyoxyanions. Now, remember the halogens; they are the group 17, okay? So fluorine, chlorine, bromine, iodine, okay? Astatine is very rare, so we don't use it a lot. So here we go. Cations. We will start with the monatomic cations, which means cations that are made of only one atom. In order to name them, basically we have to do nothing. We just use the name of the element. Now for transition metals, since those can have several ions, we have to distinguish the different ions by using Roman numerals written in parentheses. Now Ca is not a transition element, so we just call it calcium. Again, we just use the name of the element, calcium ion. H+, the hydrogen ion. Fe3+, now Fe is a transition metal. As a matter of fact, there is Fe3+ and Fe2+, both of them are very common. So we need to distinguish between them. We cannot just say the iron ion, because both of those would be the iron ions. So we need to distinguish them. This one has a 3+, so we call it the iron 3 ion. Okay, Fe2+ would be called the iron 2 ion. Okay, moving on to polyatomic cations. There are only a couple that we want you to know. And they are NH4+ and H3O+. NH4+ is called ammonium, and H3O+ is called hydronium. Okay, and this is it when it comes to cations. So let's move on to anions. As I said, they are a lot of fun. Monatomic anions, they are made of one atom only with a negative charge. So the way we name them is we use the root of the element's name and add IDE. So we add the suffix IDE. For example, F- would be called fluoride ion. O2- oxide ion, IDE. I like to say the last 3 letters because you'll see later that oxide IDE, IDE could be confused with ITE. Okay, so oxide IDE. Now N3 minus nitride IDE. So I like to say IDE because nitrite ITE exists. So I like to mention IDE to make it clear that it's not ITE, which we'll learn about later. Now that's it for monatomic anions. Now for polyatomic anions, we said we categorize them into 2 groups: the ones that have oxygen in them and the ones that do not have oxygen in them. Now let's start with the ones that do not have oxygen in them, and there is only one that you are required to know, and that's Cn- called cyanide. The oxygenated polyatomic anions, we said that there are 2 categories of them: the ones with halogens and the ones without halogens. So let's do the non-halogenated ones. As for the halogenated ones, we'll do them much later. So in order to name oxygenated polyatomic anions that don't have halogen, we use the root of the non-oxygen element's name and we add ATE. Let's hit an example right away. CO3 2-. Notice that we have carbon there and oxygen there, so there is no halogen. Okay. Now in order to name this, we have to use the root of the carbon, because we said the root of the non-oxygen element, and in this case that would be carbon. So we use the root of the element, and sometimes we don't use the root of the element, we use the whole name of the element. In this case, instead of using the root of carbon, we actually use the whole thing, and we just call it carbonate. Okay. And just with a little practice, in a few days, you will know which ones we use the roots of and then which ones we don't use their root. So it becomes automatic. PO4 2-, again, we use the root of phosphorus and then we add ATE, so phosphate. Okay, so in this case, we did use the root of phosphorus. Okay, but in this case, we actually use the whole carbon word. All right. And again, as I said, within a few days, you will know which ones we use the roots for. Now, can you guess CrO4 2-? Now, Cr is chromium, so this would be chromate. Very good, chromate. Now, there are a couple of exceptions here. Now, when there are 2 oxyanions using the same element, the same non-oxygen element, the one with the fewer oxygens ends with ITE, and the one with more oxygens ends with ATE. Example: NO2- and NO3- both have nitrogen and oxygen, but one of them has more oxygens and one of them has less. The one with less oxygens ends with ITE, so NO2- is nitrite, and NO3-, which has 3 oxygens, is nitrate. Another example, SO3 2- sulfite, SO4 2- sulfate. There are not many of these, so don't worry too much. Okay, just focus on knowing this rule and you should be fine. All right, let's hit some example, the learning check. Now, do you think you can name these? I'm going to stop here. This is what you need to do for practice, and the rest of them will do tomorrow. Let's take a look at the ones we'll be doing tomorrow. Ta-da! Here they are. These are the ones that we'll be doing in class and maybe more. And I know that you guys have been practicing this already. There were a few worksheets that we were assigned in homework, so you probably know all this. That means maybe in class we can move on to some other fun stuff. Okay, that's it for this video. See you in class.